Hello, everybody, and welcome to James's Past Papers with Live Memos. Today, we are going to be dealing with the National Senior Certificate Grade 12 Mathematics Paper 1, November 2023. Okay, so let's get started. So, we are going to start with question 1. And question 1, we're going to start with, normally what happens, guys, is that your question 1s are normally algebra. So the benefit with NSC papers is that it'll follow the same structure in terms of questions going on. So let's go for it. Okay, so 1.1.1, we're looking at x squared plus x minus 12 equals 0. Okay, so looking at the mark allocation, which is 3 marks, this is a basic trinomial factorization. So x factors of 12 is going to be 6 and 2, or 3 and 4. In this case, 3 and 4 because I want a 1. So positive 4x minus 3. I know most of you guys use your calculators for these now, which is also perfectly fine. But in the odd occasion where you don't use your calculator, here is the final answer for that question. Okay, awesome. Easy peasy lemon squeezy. Now we've got 1.1.2, 3x squared minus 2x equals 6. And then they're saying answers correct to 2 decimal places. Already a massive hint that this is going to be something that can't factorize using normal trinomial methods. We are most probably going to have to use our calculator or the quadratic formula. Okay, we're going to use the quadratic formula because we're assuming that not everyone has the calculator. So what we would do is we put it into standard form first. So that is getting everything on one side of the equals. Remember, when bringing that 6 over, it changes sign. And now it is in our standard form of ax squared plus bx plus c, which now allows me to use my quadratic formula. Now, the quadratic formula, everybody, you do get that on your formula sheet. So I'm not going to write it in. I'm just going to substitute values in. So minus b, which in this case is 2, plus minus the square root of minus 2 squared, minus 4 times a times c. A is 3, c is minus 6, all over 2, let's move this up a bit because we're getting a bit there, 2 times 3, which is a. Okay, and then we would go ahead and put that into our calculator. And the calculator will give us an answer of, first answer, remember decimals, don't have to write it in surd form or fraction form, you can go straight to the decimals. So 1,79, or x equals minus 1,12. And those are your answers. Okay, nothing more, nothing less, straight out of the calculator. Cool, next question. Let's do it over here, 1.1.3. We have the square root of 2x plus 1 equals to x minus 1. Okay, so this is a type of question when we have a root equation, which means what do we do first? We first isolate our root on one side of the equals, which in this case it already is, and we square both sides. Okay, so once we've squared both sides, the square root therefore falls away, so we're left with 2x plus 1 equals x minus 1 squared, which is x minus 1 times x minus 1. A lot of people make the mistake and they times this 2 in here and say x squared minus or positive 1. That's wrong. Remember, it is a binomial times a binomial, which means you will have to FOIL. Okay, so if we FOIL that, so 2x plus 1 equals FOIL, it's going to be x squared minus 2x plus 1. I did that very fast because I assume that you guys know how to quickly product or FOIL out two binomials. And now all we do is we make or get everything on one side of the equation. I'm going to move everything over to the right. So 0 equals x squared minus 2x plus 1 minus 1, which is therefore going to leave me with x squared minus 4x. What happens to my 1s, everybody? They cancel. Okay, now I've got a x squared minus 4x left over, which I can take a common factor out. I'm left with x minus 4. Therefore, x is equal to 0 or x is equal to 4. Are we done? No, we're not. Remember, whenever we do a squaring both sides, we always need to substitute our answers back into the equation at the top to check whether it is working or not. Okay, and 9 times out of 10, one of them will not work and one of them will work. So let's substitute it in. We're going to do our check down here. I'm going to do it in green. Okay, you can do this mentally as well. Okay, so what we would do is we would substitute the 0 back into our original equation. So this is what you would have. You would have 2 times 0 plus 1 in the square root equals 0 minus 1. Now remember, it is always assumed, not assumed, but also given, if there was a negative put in front of this, then the whole root would have been negative. But the fact that there is a positive here or nothing, it is assumed that it is a positive result when square rooting. So what do we get then? We then get 2 times 0, so square root of 1 equals minus 1. Therefore, 1 is equal to minus 1. Definitely not, which means that my x equal to 0 will not work. Let's check if my 4 will work. Let's just raise it up a little bit there. So if I substitute in 2 times 4 plus 1 equals 4 minus 1. Okay, and then let's do that. So that is therefore going to give me square root of 8 plus 1, which is 9, equals 4 minus 1, which is 3. 3 equals 3. Therefore, that one works. That one doesn't work. So my final answer here is only x equal to 4. The x equal to 0 does not work. Okay, so just to recap, guys, when you are squaring both sides, please remember to check your answers by substituting them into your original equation and seeing which one works and which one does not work. Okay, and then the last question for question 1.1 is question 1.1.4. So let's do that over here. Very common. You can always expect this in an exam. It is a quadratic inequality. Okay, so there is a little bit of a different technique to this compared to other inequalities. So what we would do is we would then get everything. We treat it as if it's a normal equation. We bring everything over and we factorize because it is a trinomial, open bracket, close bracket, open bracket, close bracket. X and x, factors of 3, that gives me 2 is 3 and 1. I need a negative 3 plus a 1 will give me a negative 2. And at this point, if it was an equation, we would say x is equal to minus 1 or x is equal to 3. But we aren't going to do that. We are going to call these values of x our critical values. So the first one would be minus 1. Second one would be 3. We would then draw a number line, and we would put our critical values on our number line, minus 1 and 3. What dots are we putting above our critical values? The fact that we have no equal to sign underneath this greater than sign, we would then put a open dot because it cannot equal my critical values. What type of graph is this? This is a parabola, and more specifically, happy face or sad face. A is positive, so it is a happy face parabola, so I can draw that in. And then what are we going to do? Remember, my y values, everything to the left of minus 1, my y values are positive. Everything to the right of 3, or everything greater than 3, my y values are positive. And everything in between my two critical values have y values that are negative. Now, my number line is complete. I've now identified my regions. Now we need to identify the answer to this inequality. Which region are we going to pick? We look at the original question again and we ask ourselves, where is this parabola greater than 0? Anything greater than 0, everybody, is considered to be positive, which means we are looking for the positive regions in this question. So you're going to take your arrows and you're going to signify which regions you're going to be taking. So we are going to take the region there. So how do we write that in an inequality? So if you are using set builder notation, we would say x must be less than minus 1 or x must be greater than 3. If you are using interval notation, we would be saying that x is an element of can't equal negative infinity to minus 1 can't equal, or 3 to positive infinity all can't equal. Both of these are the same answers. You do not need to write both. You can choose any one of these. Okay, these are the same thing. Okay, fantastic. And that is question 1.1 completed. I'm going to make that a little bit big, and I'm going to leave it on the board just for a little bit so that you guys are more than welcome to take a screenshot and pause it. Okay, fantastic. Let's move on to 1.2. Now 1.2, I'm going to cut out here and I'm going to move down here. 1.2 is a simultaneous equation. Also, guaranteed to get one of these in your test. Easy marks in my opinion, so let's just make sure that we get them. So what are we going to do? We have our two equations. The first goal is to identify. So what I would do is label my equations. So I would say x plus 2 equals 2y dot dot dot. That's my equation 1. And then I've got 1 over x plus 1 over y equals 1. That is my equation 2. Now, the easier one out of the two equations to make either x or y the subject of the formula would be equation 1. So let's get x by itself. You want to avoid making fractions as your third equation. We are using the substitution method of simultaneous equations here. So let's make x the subject. So it's going to be x is equal to 2y minus 2. That would be my third equation. We now sub equation 3 into the equation we didn't use to make equation 3, which is equation 2. So let's sub it in. So we're going to have 1 over 2y minus 2 plus 1 over y equals 1. When adding and subtracting fractions, everybody, what do? We establish an LCD. Okay, and our LCD in this case is going to be, I'm just going to write it out here, y 2y minus 2. Okay, so we are going to apply our LCD. So this is going to be y plus 2y minus 2 equals y 2y minus 2. Okay, and what I'm going to do, I'm just going to take that up here and continue it here. So we'll times that out. So it'll be y plus 2y minus 2 equals 2y squared minus 2y. Now let's bring everything over to the right because we're going to end up most probably with a quadratic equation. So let's say 0 equals 2y squared minus 2y minus 2y minus y plus 2. Okay, remember when taking stuff over the equals, guys, you change your signs. 0 is therefore equal to 2y squared minus 5y plus 2. And let's factorize that. 2y. Okay, I'm already putting that in because I know factors of 2 is 2 and 1. Factors of my last is also 2. So it's definitely going to be 2 and 1 here, and most probably minus. Okay, and there's going to be a y. So we now have our equation. So y is going to equal to a half, or y is going to equal to 2. Okay, so that's just making my brackets separately equal to 0 and solving for y. Now I've got my y's. You now can sub your y's, sub y values into equation 3. Okay, that is now to establish my x values because we are simultaneously solving for both x and y. So let's sub that in. So let's use our third. Why am I choosing the third equation, everybody? Because it's already in the form of x equals. So I don't need to really do any algebra. I can just plug this into my calculator. Or x is equal to 2 times 2. Let's just make this a bit bigger so we can fit everything on one page. And it's going to be minus 2. Okay, so this is going to be 2 times a half is 1. 1 minus 2, so x is going to equal minus 1. And this x is going to equal 2 times 2 is 4, minus 2 is 2. Okay, now normally you can represent your answers in certain ways. I like to use the coordinate method, which I think memos are also prone to do. So let's put the first one is going to be when x equals minus 1, y is equal to a half, or we've got when x is equal to 2, y is equal to 2. And those are my two answers for this question. Okay, fantastic, awesome. Let's move on to question 1.3, which is normally your hardest question out of question 1. It's always that one people are a little bit doubtful for, and it is definitely the hardest question. Okay, so let's take it out there. Let's do, okay, cool. So here they've given us a bit of a difficult exponential equation or question. So what we will do when we see a plus and minusing of exponential expressions. We want to separate our terms. So I'm just going to rewrite the question quickly. Plus 2 to the m equals 3 to the n plus 2 minus 3 to the n. Okay, so it says there, given that where m and n are integers, so integers, remember guys, are whole numbers on the positive and negative side of the number line spectrum. And then it says determine the value of m plus n. Okay, so the goal here is to drop the bases and just get the m and the n's in an equation by itself. So let's see what we can do. So first thing that I would do here is separate my terms. That's my go-to. Whenever I'm plussing and minusing with exponential expressions or equations, I always separate my terms. I basically do the reverse laws. Okay, so that what I've done from here to here is the reverse law of law 1. When timesing values of the same base, we add the exponents, right? So I've just done the reverse law, and then the same with the 3 to the n plus 2, 3 to the n times 3 to the 2 minus 3 to the n. What that actually does for me, guys, is it then shows me, oh, I can see a common factor. So let's take 2 to the m out as a common factor. I'm left with 2 to the 1 plus 1 equals 3 to the n, open bracket, 3 squared minus 1. Remember, when you take the whole thing out as a common factor, there's always a 1 left over there, not nothing. Okay, awesome. So now that we have that, we can then simplify our answers. So let's see what we got here. So we've got 2 to the m 3 equals 3 to the n times 9 minus 1, which is 8. Now we've actually got our answer, and it's a matter about making the left-hand side look like the right-hand side. Sounds a little bit like an identity, doesn't it, from trigonometry? But basically what we've established here is that 2 to the m on this side must be the same as whatever that is. And 3 to the 1 must be the same as 3 to the n. Okay, because the sides need to look the same because they're equal, right? So 3 to the 1 must equal 3 to the n. So let's take that out. So 3 to the 1 must equal 3 to the n if these two are both equal, right? And 2 to the m must equal the 8. And there you've kind of created two separate equations that you can now solve for. So therefore 1 has to equal n. And here we first need to change the 8 into a base 2, which is that. Therefore m equals 3. And now we can actually solve for our question and ask, what is the value of m plus n? So m plus n is equal to 3 plus 1, which is equal to 4. Okay, so a little bit of a tricky question, but we established, so we basically simplified it up until a point. So from here to here is your simplification, to a point where the left-hand side looks a lot like the right-hand side, and it was a matter of making the 3 look like the 3 and the 2 look like the 2. Okay, awesome. That is question 1.